All right, let's go ahead and finish up chapter 3 today. We took the test last week. This week we're just going to finish up with kind of some algebra-based ideas involving parallel and perpendicular lines, so writing equations, given a graph, determining which lines might be parallel or perpendicular or neither. And so we're going to venture a little bit further into more of an algebra-type base lesson than necessarily a geometry. So the first thing, just kind of a reminder, slopes of parallel lines. So we said in geometry, parallel lines are any that go the same exact direction. So anytime two lines are going exactly the same direction, they're never going to intersect, they're parallel. Now, algebraically, if I have two parallel lines, it means that they have exactly the same slope as each other. So whatever the slope of one line is, the slope of the parallel line will be exactly the same. So basically, if I have the slope of line 1 is some slope a over b, then my parallel slope would be a over b. They're going to be exactly the same. Okay? So parallel lines always have exactly the same slope. Now, with that in mind, this second point right here says that if I have two vertical lines or if I have two horizontal lines, those lines are going to be parallel by default. So two horizontal lines are both going to have a slope of 0, so that means they're both going to be parallel. Or if I have two vertical lines, they're undefined, that means they're both going to be parallel to each other. So vertical and horizontal lines are parallel to each of their respective pieces. Otherwise, we need to check the slope of the two lines and make sure that they are exactly the same. For perpendicular lines, we use the phrase opposite reciprocal slopes. Okay, so the opposite refers to changing the sign, plus to minus or minus to plus. The reciprocal means flipping a fraction. So a over b becomes b over a. So as far as opposite reciprocals, we need something that has a different sign, one slope positive, one slope negative, and then reciprocal means they flip the fraction. So if I have the slope of one line as a over b, my perpendicular slope, so there's my symbol for perpendicular, my perpendicular slope would have to be negative b over a. So I'm just going to flip the fraction and change the sign. The same thing applies to if I have a negative slope to begin. So if I had a negative a over b, then my perpendicular slope would be positive b over a. So the sign changes and the fraction flips. Okay, so those are perpendicular lines. So one of the first things they're going to ask you to do is, given a set of lines, which ones are parallel, which ones are perpendicular. So to do that, we need to find slope. Now, slope can be found three different ways depending on the information given to you in the problem. If they give you a graph like this, we're going to use counting methods to find slope. So if I want to find the slope of line A, so my blue line right here, they give me 2 points on that line. So I'm going to use those 2 points, and I'm going to count. So slope from a graph, if you remember, is rise over run. How far up and down versus how far left and right. So when I calculate slope, I'm going to start at the farthest left point. So I'm going to start right here. And I'm going to count up or down first. So I'm going to go up 1, 2, 3, 4. So I got a positive 4 for my rise. And then I go to the right 2, so right would be positive, so right 2. When I write my slope, I'm going to reduce any fractions that I can, and I'm going to keep them in fraction form. So 4 over 2 reduces to 2 over 1, and so there's my slope for line A. For line B, which is in red, they give me these 2 points here. Again, I'm going to start on the left and work my way to the right, so I'm going to count up 1, 2, 3, 4. So for my slope of line B, up was positive, so 4, and then to the right, 2. Right is also positive, so 4 over 2 reduces to 2 over 1. Then I've got line C. So line C, they give me these 2 points here. When I go to calculate slope, again, I count. Starting at the left, I go up 1, 2, 3, so positive 3 for rise. Then I go right 1 for the run. And so I get 3 over 1. That doesn't reduce down. We just leave it as 3 over 1. And then my last line in purple there is D. So I'm going to find the slope of line D. So for D, I find 2 points. So we got these 2 points here that I highlighted. And then again, I'm going to start with the left point and I'm going to count to the other. So I go down 1. Down would be a negative, so I get -1 for my rise. And then I go to the right 3. So right is positive, and so I get -1/3, which doesn't reduce, so I just leave it as is. Now, as far as identifying parallel and perpendicular lines, okay, at this point, any slopes that are the same, so parallel means the same. So if I look at the problems here, the only two that have the exact same slope are A and B. So A and B must be parallel. So for my answer, I'm going to say line A is parallel to line B because they have exactly the same slope. None of the other lines have exactly the same slope, so those are my only parallel lines. Now for perpendicular, so for perpendicular, I need opposite reciprocal slopes. I need the opposite signs and I need the fractions to flip. So if I look at my different slopes here, I notice that 3/1 and -1/3 are opposite reciprocals. One's positive, one's negative, and I notice that my two fractions are just flipped, 3/1 versus 1/3. So that means line C and line D are perpendicular to one another. So line C is perpendicular to line D. Those are my relationships between the lines. So finding slopes for each of the lines given, any that are exactly the same are parallel, any that are opposite reciprocals are perpendicular. As far as slope is concerned, there are two other ways to calculate slope, one of which we've talked about before, but just kind of as a review, given 2 points, I can calculate the slope of a line using the following formula here. So if I have 2 points, I could calculate slope using this y minus y over x minus x. And so here we have y2 minus y1 over x2 minus x1. The key here is just making sure that when you subtract in the same direction. So I went y2 minus y1, and then I went x2 minus x1. Just go same direction both times you subtract. Once you get that final value, you just reduce down and then compare slopes. The third method for finding slope is if they give you an equation. So if they give you an equation, now they might give it to you in like a standard form, ax plus by equals c. Okay, if that's the case, you need to take an equation like that and you need to convert it into your slope-intercept form. Basically meaning we need to solve for y. So any equation we get y completely by itself, and once we do that, my slope, which is always denoted with a lowercase m, my slope is going to be the number attached to x. So if I have a graph, I can count from one point to the next. There's my slope. If they just give me the 2 points, I can plug it into my formula, y minus y over x minus x, reduce the fraction, and there's my slope. Or if they give me an equation, get y completely by itself, and then the number attached to x will be the slope of my line. So, again, we're still going to be identifying parallel and perpendicular, but now we might use different formats to calculate slope and determine what's going on. So it says here, determine if the lines are parallel, perpendicular, or neither. Now, if I don't get exactly the same slope, or if I don't get opposite reciprocal slopes, then those two lines aren't either of the parallel or perpendicular variety. So if I'm given 2 lines, so right here, they give me 2 lines, so they give me points on those. To calculate slope, I'm going to use that formula. So this is the second method for finding slope. So slope of line 1 here is going to be y minus y, so 4 minus 0 over x minus x, so 7 minus 1. And so if I do my subtraction here, 4 minus 0 is 4, 7 minus 0 is 6. I can take that 4 over 6 and reduce it down to 2/3. So there's my slope for line 1. Then I look at the slope of line 2. So for the slope of line 2, I do the same thing. Y minus y, so 6 minus 0 over x minus x, 3 minus 7. So 6 minus 0 is 6. 3 minus 7 is -4. Now, when we get a fraction like this, where we get a negative, that negative can go anywhere in the fraction. So right now it's in the bottom, but we typically like to move it out front or to the top. So when I go to reduce, 6 over 4 goes down to 3 over 2. So I'm going to write -3 over 2, because that negative can move wherever. Now, take a look at these two slopes. We've got +2 over 3 versus -3 over 2. I've got one positive, one negative, and the fraction flipped. That means line 1 is perpendicular to line 2. That's my final conclusion. So they're perpendicular to each other because their slopes were opposite reciprocals. If I look at my second example, so here I got my two lines. I find the slope of line 1. So I take 7 minus 3 over -5 minus -9. And so 7 minus 3 is 4. -5 minus negative becomes plus, so -5 plus 9 gives me 4. And so I get a slope of 1 over 1. When I go for the slope of line 2, I have 2 minus 6 and -7 minus -11. And so 2 minus 6 is -4. -7 plus 11 is +4. And so in this case, I get a -1 over 1. Now, if I look at this one's kind of a special case for slopes. Notice I got 1 over 1 for both. So when I flip 1 over 1, I get 1 over 1 again. So then the thing I have to pay attention to here is one's +1, one's -1. So because I have one positive, one negative, and the fractions are flipped, that means these lines are also perpendicular to one another. So line 1 and line 2 are perpendicular. If in either one of these cases I had gotten exactly the same slope, then I would have said that the lines are parallel. And if I got anything else, I would say that the lines are neither. So they're not parallel or perpendicular. So find the slopes, compare them, make your determination based off of that. The next one then, we're looking at identifying parallel and perpendicular given equations. So I've got my first two lines right here. Now if I have equations, I need to get y completely by itself. So for line 1, there's a little bit of work that I have to do here. I'm going to have to get y completely by itself. So the first thing I'm going to do is take the 3x and move it over to the right side. So I'm going to subtract 3x. Now that leaves me with a -2y equals -3x plus 16. I can't combine the 16 and 3x because one has x, one doesn't. So now once I'm here, I still need to get that -2 off of the y. So I'm going to divide everything by -2. And when I do that, my -2's here cancel, so I get y. -3 over -2, the negatives cancel out, so I get +3 over 2x. I leave it in fraction form, and then 16 divided by -2 gives me -8. So here is the equation for line 1. That means my slope is that number attached to x. So the slope of line 1 is +3 over 2. If I look at my second equation, y is already completely by itself, which means I don't have to do anything with this equation. So for line 2, y is equal to -2/3 x plus 1. There's nothing that needs to be done with it. So all I have to do is identify slope. So if I look here, I get -2/3 for my slope. And so if I look at my results, +3 over 2 compared to -2 over 3 means that line 1 is perpendicular to line 2. So I got opposite reciprocal slopes. My lines must be perpendicular to one another. Okay. When we go to the next example here, so just clear up some space there. So when I go to my next example, so right here, I'm going to kind of do the same thing. I need to first take line 1, and I need to solve for y. So in this case, all I have to do is move the 2x over. So I got y is equal to -2x plus 5. That means this -2 is my slope. Now, if I get a whole number like that, when I write my slope for line 1, I'm going to write it in fraction form, which means -2 over +1. Okay, so we always write our slopes in fraction form. Next, I'm going to do line 2. So for line 2, I have some work to do. I'm going to start by taking my 6x and moving it over to the right. So I get 3y is equal to negative 6x plus 36. And then I still need to get rid of the 3, so I'm going to divide everything by 3. And so I get y is equal to negative 2x plus 12. And again, I look at what's in front of x. So negative 2, so then I write it in fraction form. The slope of line 2 is negative 2 over 1. Notice that the two lines have exactly the same slope. That means line 1 is parallel to line 2. So same exact slope means the lines are parallel. Okay, in our last example, so in this last example here, same exact idea. We need to get y by itself. So for line 1, I'm going to go ahead and move the x. 3y equals negative x plus 11. Divide everything by 3, so y is equal to negative 1/3 x plus 11/3. Just leave everything in fraction form. And then I do line 2. Line 2 is good. Negative 2y equals negative 5x plus 6. Y then would equal 5/2 x minus 3. So when I divide everything by negative 2, I leave fractions in fraction form. So now if I look at my slopes, I've got a negative 1/3 and I've got a positive 5/2. Well, those are definitely not the same. If I look at opposite reciprocal, I don't have the same fraction. I have 1 over 3 and 5 over 2. So in this case, these lines are neither. They're not parallel because they're not the same. They're not perpendicular. They're not opposite reciprocals. Okay? So with that, you should be able to complete that first day of worksheet. So just finding slopes and then using the slopes to determine whether or not the lines are parallel or perpendicular. So given a graph, count, find your slopes, compare the slopes. Given 2 points, calculate the slope, and then compare. And then if you're given the equation, solve the equation for y, find the slopes in each equation, and then compare. If they're exactly the same, parallel, opposite reciprocals, perpendicular. If they don't match up at all, then they're neither. So you should be able to attack that worksheet now. If you have questions, ask in class or email, and then we'll kind of move on from there.